Hello to my dear students. So, how you all are good? Yes, I hope you all are fine. You are safe in these conditions. Yes, and please be at home. Don't move out unless it is very essential to go out. Okay, right. So, this is one of the session which every student was demanding since long. Hello to my dear students. So, shit. How you all are good? Just a minute. Just a minute. I hope you all are fine. Here. You are safe in these conditions. Okay. I opened the. Okay. Right. So, yeah, very good evening. Very good evening to all my students. Right. So, this is a very good session that I've introduced for you all. It's a very important session for all the students who are planning for the interviews in any of the exam. Whether you take any exam, this is one of the session that is going to help you a lot. Yes. So first I would like to see the attendance of all the students. Those who are just joined the session, please hit the like button so that we can know how many of you are actually studying over this channel. Yes. Come on everyone, like the session. Yes. And please share this link with your friends so that more and more students can join this particular session in the live only. I don't want to go for the any other session. Yes, I want to go in the live session. Yes, very good, very good. Yes, very good. Very good evening, Avinash, Verma, Naman, Sunil. Yes, Kaloke and Negi both, and Sagar. Yes, come on everyone, please join the session and hit the like button so that we can know how many students are actually there, and hit the like. Share this with your friends so that more and more students can join this session soon. Yes. So as you know about me, myself, Abhishek Sir, I've been teaching this field since 5 years, right? And I've qualified GATE 5 times. And in the ESE pre and mains, after the interview, I got a score of 637 in GATE in the ESE 2015. I used to take 7 subjects. So I would be trying my level best to bring all the questions in the interview that comes, right? So if you are planning for the Unacademy subscription, you can use my code, that is BART10. As my name is Bhartiya, the most of you know me as a Bhartiya sir. So I've kept the code as a BART10, and 10 is obvious, that's for 10% discount. So let me start the session. The one thing that you should be very clear for any interview, is that this interview doesn't demand that you need you have very high technical knowledge. No. You require to cover some basic subjects. And what are these subjects? Subjects are strength of material, geotechnical engineering, RCC, BMC, modern architecture works and materials. So these are the almost 5 subjects which are highly demanded in the interview. So if you are preparing these subjects, you need to prepare these subjects not only in respect to your technical knowledge for solving the question, but also for your interviews. And we as a mentor are very enthusiastic to explain these concepts. So today this is a very energetic session. This need to be very energetic session. Yes, this need to be very energetic session. I will be guaranteeing you that. We will be putting the questions directly one after the another, and you need to answer that, or I will be answering that, right? So talking about the next part, and before taking the next part, I'm going to answer the question of Inash. Sir, I have one question. Why classes are not running Zenith batch? Obviously it is running better. The morning batch of 7 to 10:30 is a Zenith batch only. That is 7 to 9 and 9:30 to 11 is a Zenith batch only. Yes, this is going to be very energetic session. And as you know about me, the energy level is always very high. It can never go down. Okay. So I will be taking today strength of material. And we'll put questions one by one. So first question coming in your way. What is the shear force and bending moment? Yes. The first of all, what do I know about this? The shear force and bending moment both are internal resistance. The first point. Second point, if you have to say about the shear force and bending moment, that shear force is the summation of all the transverse force while moving left to right or right to left at any section. And if I talk about the bending moment, it's a summation of all the moments caused due to transverse force or concentrated moment while moving left to right or right to left at any section. तो आपको अगर कोई बोलता है कि बताओ व्हाट इज अ शियर फोर्स एंड व्हाट इज अ बेंडिंग मोमेंट इन द इंटरव्यू, समवन आस्क्ड यू, तो आप क्या जवाब होना चाहिए? फर्स्ट ऑफ ऑल, बोथ आर इंटरनल रेजिस्टेंस. सेकंड पॉइंट, shear force, the summation of all the transverse force while moving left to right or right to left at any section. And what is the bending moment? Summation of all the moments caused due to transverse force or concentrated moment while moving left to right or right to left at any section. Okay, so that is about the shear force and bending moment. Now the second important thing that they can ask from the shear force and bending moment is, what is the importance of shear force and bending moment? Why we draw the shear force and bending moment? What is the need of shear force and bending moment? Yes, what is the need of shear force and bending moment? Yes, who can tell me? Who can tell me what is the importance of shear force and bending moment? Yes, what is the importance? Why we draw? If we are doing the engineering, we are doing something, we are drawing the shear force and bending moment. So what is the importance? Why we need to draw the shear force and bending moment? Yes, who can answer me this question? Who can answer me those questions? What is the importance of shear force and bending moment? Why we draw the shear force and bending moment? Yes, who can answer? Everyone please hit the like button, those who have joined just now, and share this with your friends. Yes, yes, yes. Come on, answer me this question. What is the importance? Yes, design. Very good. See, the first thing is, when you draw the shear force and bending moment, what you find actually, you find the shear force and bending moment at each and every section. Okay. So at any section from the bending moment diagram or shear force diagram, you can find what is the value of maximum bending moment or the value of maximum shear force, and correspondingly you can find what is the maximum bending stress, that is the bending strength, and correspondingly what is the shear strength, and based on that you can design the material by taking the section modulus. Okay, so that is the importance of shear force and bending moment. Okay, so that is the importance of shear force and bending moment. Okay, so this is one of the very good question asked in the interview. First they will ask what is shear force and bending moment. Once you answer that question, they will ask you that what is the importance of shear force and bending moment. Okay, so moving to the next question. What is principal plane? What is principal plane? What is principal plane? Yes, what do you know about principal plane? What is this principal plane? Yes, yes. So how you are going to answer? How you are going to answer that what is principal plane? Listen to me very carefully. When you say just like this, it is from a point at a plane, the shear stress is 0, then the plane is referred as principal plane. This is not actually a right answer. If you say like this, they're not going to give you any marks, right? Because that's a general answer. How you are going to represent? You are going to say that from a point, due to the loading from a point, infinite number of plane can pass. And out of this infinite number of plane, there exist 3 mutually perpendicular plane. Out of this infinite number of plane, there exist 3 mutually perpendicular plane at which shear stress is 0. At which shear stress is 0. Right? So, such a plane is referred as principal plane. Such a plane is referred as principal plane. Right? Abhinash, telling that plane about which the object fell is a wrong statement. Right? Telling that plane about which the object fell is a wrong statement, because we have seen that in a ductile material, the failure plane is the maximum shear plane, and in the brittle material, the failure plane is the maximum principal plane. So saying that plane about which the object fell is a wrong statement, right? Because it depends on the material, it depends on the loading, right? First thing. Thereafter, when you answer that what is a principal plane, the next question they are going to ask you is, what is principal stress? So what you are going to answer in this? What you are going to answer in this? When you have explained what is a principal plane, that it is a plane at which shear stress is 0, considering everything that I told earlier, then what you are going to say? The normal stress acting on the principal plane is the principal stress. The normal stress acting on the principal plane is the principal stress, right? Thereafter, what you are going to say? It is the maximum or minimum value of normal stress that can exist at a point. It is a maximum or minimum value of normal stress that can exist at a point. Okay, that is the principal stress. Okay, is it clear? Is it clear to all? Is it clear how you are going to frame your answer? Is it clear? Yes. How you are going to frame your answer for these type of question? Is it clear to all? Yes, tell me. Tell me yes, is it clear to all? Tell me yes. I'm telling you, this will be a very energetic question, energetic session. The questions are very good, right? These are commonly asked interview questions, and I'm giving you answer also to this question, that how you are going to represent. Yes. Okay. Okay. So coming to the next question. Answer me. For hydrostatic loading, how many principal plane exist? For hydrostatic loading, how many principal plane exist? For hydrostatic loading, how many principal plane exist? Yes. For hydrostatic loading, how many principal plane exist? Yes. Come on, tell me fast. For hydrostatic loading, how many principal plane exist? Yes. Come on, answer me this question. For hydrostatic loading, how many principal plane exist? Yes. Come on, answer. What will be your answer? For hydrostatic loading, how many principal plane can you see? How many principal plane exist? Shankar Narayana is saying 3. Yes. Yes. Others infinite. Sunil is saying infinite. Naman is saying infinite. Malaya is saying 3. Okay. Anyone else? Anyone else? Suresh Chandra is saying 1. See dear, I have already told you, in a hydrostatic loading, first of all you should know what is hydrostatic loading. When I say hydrostatic loading, so in a hydrostatic loading on the mutually perpendicular planes, the stresses are equal, the normal stresses are equal and opposite, and there is no shear. So all the planes will be shear plane, and if all the planes are shear plane, that is equal and alike forces, if you see, and if all the forces are same, all the stresses are same, you will see that you can see that there are infinite number of principal plane. For any value of theta, shear stress will be 0. So there are infinite number of principal plane. This I have already told you when I was dealing the principal stress chapter, right? So there is this infinite principal plane. Yes dear everyone, please like the video and share with your friends. I want more students. The next session I want more students to be live here, and this session also I want you everyone to share this video with your friends and tell them to come to this session. This session will be helpful to you, right? Okay, next question. How many shear plane exist at a point in 2 dimension? Come on, answer this question. How many shear plane, maximum shear plane exist at a point in 2 dimension? Think and then answer. Think and then answer. In 2 dimension, I'm saying how many principal plane exist at a point. That's how many maximum shear plane exist at a point in 2 dimension. Yes, everyone, answer me this question. How many maximum shear plane exist at a point in 2 dimension? Yes, answer me this question. How many maximum shear plane exist at a point in 2 dimension? Yes, come on, answer me this question, beta. 1. Naman is saying 1. Malaya is saying 2. Yes, others, please reply. Please reply. How many maximum shear plane exist at a point in 2 dimension? Vishnu is saying 1. Okay. Others, please reply. Others, please reply to this. Others, please reply to this. How many maximum shear plane exists at a point in 2 dimension? Okay. Now I'm going to answer this question. We know that in a 2 dimension there are 2 principal plane. Yes, which are mutually perpendicular to each other. So the shear plane is equally inclined to these 2 planes. So obviously you can see only one. The other which you see is a complementary. The other is complementary in that plane. Okay. So you have 2 principal plane in 2 dimension, right? You have 2 principal plane in 2 dimension. So the maximum shear plane is equally inclined to these 2. So there you will see only one. and the other part that you are going to see will be a complementary shear. Okay, right? Is it clear to all? So there is only one maximum shear plane that exists at a point in two dimension. There's only one maximum shear plane that exists at a point in two dimension. Yes, is it clear to all? Yes, is it clear to all? Yes, yes, very good, very good, very good. Next question coming up. Next question coming up. Next question coming up. I'm telling you, this will be a very energetic question, but you, if you are live, you are going to enjoy. Recorded, it's okay, but live का मजा ही अलग है यार. चलो next. Yes. In pure shear condition in a ductile material, what is the inclination of failure plane with respect to horizontal? In pure shear condition in a ductile material, what is the inclination of failure plane with respect to horizontal? Yes, in pure shear condition in a ductile material, what is the inclination of failure plane with respect to horizontal? Yes, come on, try to answer this question. Try to answer this question. 45. Suresh Chandra is saying 45. Sankar Narayana is saying 45. Okay. 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 Yes. Naman is saying 45. Malya is saying 45. Okay. Very good. Very good. Very good. Others. Sunil is saying 45. Okay. Now just try to understand my situation. We know that in a ductile material, the plane of failure is the maximum shear. The plane at which the maximum shear stress you can see, there the failure will occur. And in a pure shear condition, the maximum shear plane is at 0 degree with respect to vertical. The maximum shear plane is at angle of 0 degree with respect to vertical. Yes or no? The maximum shear plane is at an angle of 0 degree with respect to vertical. Yes? Is at angle of 0 degree with respect to vertical. Right? So, if the maximum shear plane is at angle of 0 degree with respect to vertical, the failure will occur at this plane only. The failure will occur at this plane only. So I am asking the angle with respect to horizontal. I am asking angle with respect to horizontal. So obviously the angle is 90 degree. It is not 45 degree. Is it clear? Is it clear? Yes. Suresh, Shankar Narayana, Naman, Malya, Sunil and others. Is it clear to all? Is it clear to all? Yes. Is it clear to all? Is it clear to all regarding this question? Yes. Is it clear to all? Tell me dear, is it clear to all? Is it clear to all? Yes, yes, yes. Is it clear to all? Okay, very good. Very good. Okay. Next question. Next question. Next question. What is stress invariant concept? Someone asked you what is stress invariant concept. What answer you are going to give? What answer you are going to give? Sir, in the cup and cone, it is not a pure shear condition. It is the material is subjected to tensile loading. And due to the tensile loading, the maximum shear plane is coming at angle of 45 degree. And that is the reason that the angle is 45 degree with respect to horizontal. Yes, Rishabh, you can ask your question. Yes, Rishabh, you can ask your question. Let me complete the stress invariant. Till that time, you write your question. So, what is the stress invariant concept? The stress invariant says that at a point, the summation of normal stress, on the mutually perpendicular plane, are equal. Summation of normal stress on the mutually perpendicular plane at a point is same, is constant. That is the stress invariant concept, and we have solved many questions on this also. Yes, yes, very good, right? So that is your stress invariant concept. Okay, Rishabh, I am waiting for your question, beta. Rishabh, I am waiting for your question. Rishabh, I am waiting for your question, beta. Okay, so let's see the next one then. Let's see the next type of questions on the strength of material. First question, what is Mohr circle? When someone says you that explain me what is a Mohr circle, what you are going to write? What is a Mohr circle? Yes. So Mohr circle is what? It is a graphical representation of the stresses acting at a point. When you say stress tensor, it is what? Just a representation. We say that is just a representation. When you say Mohr circle, it is a graphical representation of all the stresses that are acting at a point. So for representation, you know, you require infinite. That means from a point there are infinite number of planes, each having a definite value of normal and shear. So when I say what is Mohr circle, when you need to explain the Mohr circle, what you are going to write? It is the graphical representation of the normal and shear stress acting on a plane at a point. Acting on a plane at a point. Yes. Next, Rishabh is saying which theory of failure is applied to which type of material. Rishabh, telling you very clearly, if you take your basic concept like your Saint Venant's principle or your maximum shear stress theory, or that is Tresca's theory, or you take the Beltrami-Heath's theory or von Mises-Hankey's theory, all these are for ductile material. And when you take the Rankine's theory or the Mohr-Coulomb's theory, these are for brittle material. Okay, Naman is saying properties which does not change by the matrix transformation. All the properties will be changed. What kind of properties will not change? You are changing from stress to strain, so obviously it will change. Yes, strain is also invariant, beta. Strain is also invariant. Yes, Sunil, strain is also invariant. Yes, yes. Okay, so next question that can be asked. What is the Mohr circle? They can ask you to draw the Mohr circle for the pure shear condition. So you know that it is a circle that passes through the center, that has the origin at the center, right? And all the maximum principal, minimum principal and maximum shear all have the same magnitude. So you can draw that. Next question they can ask, if the angle between two principal plane in a structural element is h, if angle between the two planes in the structural element is h, then in the Mohr circle it will be, come on, answer this question. If the angle between the two planes in the structural element is h, then in the Mohr circle it will be, yes, then in the Mohr circle it will be, tell me dear, then in the Mohr circle it will be, what will be your answer? 2h. Naman is saying 2h. Malya is saying 2h. Yes, others? What others are saying? Naman is saying 2h. Malya is saying 2h. What others are saying? Navraj is saying 2h. Okay. Okay. Others. Yes. Yes. Yes, it is 2h. Very good. In the Mohr circle, we know that the angle will be 2h. Yes. Next question. Yes, very good. In hogging bending moment, the maximum tension occurs at which fiber? In hogging bending moment, the maximum tension occurs at which fiber? In hogging bending moment, the maximum tension occurs at which fiber? Yes, in hogging bending moment, the maximum tension occurs at which fiber? Yes, what will be your answer? Top fiber or bottom fiber? Top fiber or bottom fiber? Yes, in the hogging bending moment, the maximum tension occurs at which fiber? Top fiber or bottom fiber? Yes, top fiber or bottom fiber? Come on, everyone, tell me. Topmost. Naman is saying topmost. What others are saying? Topmost or bottommost? Yes, topmost. Very good. It's a topmost fiber. Very good. So I move to the next question. Moving to the next question. What is the difference between neutral fiber and neutral surface? What is the difference between neutral fiber and neutral surface? What is the difference between neutral fiber and neutral surface? Yes, tell me fast. What is the difference between the neutral fiber and neutral surface? Yes, everyone tell me. What is the difference between neutral fiber and neutral surface? What is the difference between neutral fiber and neutral surface? What you are going to answer? What you are going to answer? What is the difference between the neutral fiber and neutral surface? Yes, we know that it is a neutral surface, the surface, right? That is a plane at which if the bending is applied, the dimension of the plane is not going to change, and the intersection of the neutral fiber with the transverse cross section will give you neutral fiber, that is referred as neutral axis. Yes, so that is the difference in neutral fiber and neutral surface that you are going to say. Next, what are the assumptions in the bending? Yes, very good. Okay. No, Naman, no. Right. What are the assumptions in bending? We say that material is homogeneous. We say that material is isotropic. We say that the material is linearly elastic. Right. Then we say that material is prismatic. Okay. Then plane section before bending remains plane even after bending. Then what we say? That next part, the loading is symmetrical. The loading is symmetrical. The Young's modulus is same in tension and compression. Then we say that if the structure is unsymmetrical, then the load must pass through a point that is a shear center. That is a shear center, right? At the point where if the loading is passed, the twisting moment in the structure is zero. So all these are assumptions in bending. What are the assumptions? Homogeneous, isotropic, linearly elastic, prismatic, okay, symmetrical loading. Then what we said, your plane section before bending remains plane even after bending. Then what we said, that Young's modulus is same in tension and compression. And last, if the structure is unsymmetrical, then apply the load through shear center. So all these are assumptions that you can say in the bending. Okay, next part of the strength of material. What is homogeneous and isotropic? You are told in the assumption homogeneous, isotropic, everything. So what is homogeneous and what is isotropic? Yes, they will ask you link. They will ask the linking between the topics. So you need to link the topics, right? So what is homogeneous and what is isotropic? Yes, come on, tell me first. What is homogeneous and what is isotropic? Yes, homogeneous means at a point within a body, that all the points within a body in one particular direction, the material elastic property will be same, right? And when I say about isotropic, then it considers a point, and at a point in all the direction, the material elastic property will be same. That is the meaning of isotropic. Okay, everyone please like the video, dear. We are putting so much effort for you all, right? It's your duty to like the videos. Yes, very good, Ashwarya, Naman, very good. Next, what do you understand by linearly elastic material? What do you understand by linearly elastic material? Yes, who can tell me what do you understand by linearly elastic material? Yes, what do you understand by linearly elastic material? Tell me, dear. We know that it is a material at which Hooke's law is valid. So as soon as you tell that Hooke's law is valid, the next question that will be asked from you is, what is Hooke's law? The next question that will be asked from you is, what is Hooke's law? So one thing that you should be very clear while explaining the Hooke's law is, within the proportionality limit, if you miss this point, that within the proportionality limit, they will cut your marks. So when you say Hooke's law, you have to say that within the proportionality limit, stress is directly proportional to strain. Stress is directly proportional to strain. That is the Hooke's law. Okay, next. What is shear center? You have mentioned in the assumption that shear center is there, right? So what is shear center? The next question they can ask you, what is shear center? So we have already discussed that. It is a point through which if the resultant loading is passed, then the net twisting moment in the structure will be zero. Net twisting moment in the structure will be zero. So that is your shear center. Next point. They will ask you next. Yes. We say generally the statement Naman, you have to write up to the proportionality limit. That means in this up to it is considering the entire range, right? So that is within the, when you say within the proportionality limit, you are considering each and every point. So you write within the proportionality limit, stress is directly proportional to strain. Okay, next. What is the variation of bending stress at a cross section? What is the variation of bending stress at the cross section? Yes, how the variation will be there? How the variation will be there? How the variation will be there? What is the variation of bending stress at the cross section? Yes, come on, tell me. Yes, it will be linear with the maximum at the surface and minimum at the center. Yes, so that is the variation of bending stress. At the over top fiber, if it is tension, then the bottom will be compression. If at the top it is compression, then the bottom it will be tension. Yes? Okay. Shall we look to the next question? Yes. What is section modulus? Explain its significance. The next interview question that can ask from this bending part will be, what is section modulus? Explain its significance. What is section modulus? Explain its significance. Yes. What is section modulus? Explain its significance. So what you are going to answer? What you are going to answer? What is section modulus? Explain its significance. Yes. What is section modulus? What is the significance of this section modulus? It represents the strength of a section. Okay, very good, Durgesh. It represents the strength of a section. It's a very good answer. Then what is its significance? Then what is its significance? What is its significance? I'm not asking a formula or anything else. I wanted what is the section modulus? You told that it represents the strength of a section. That's very good. Then what is the significance? What is the significance of the section modulus? What is the significance of this section modulus? Yes? Come on, who can tell me? What is the significance? You are telling that it is defines the strength of a section. So significance is that if I increase or decrease the section modulus, I can increase the load carrying capacity or I can reduce the quality of a material, right? That we have already discussed when we were discussing about the section modulus, right? So you can mention about this. Okay. Next. What is the use of flinches in a flinched beam? What is the use of flinches in a flinched beam? And are the flinches made up of stronger or weaker material than the original bar? That's original beam cross section if you take, then compared to the original cross section, the flinches that you are taking are made up of stronger material or weaker material. Come on, answer me this question. What is the use of flinches in a flinched beam, right? And are these flinches made up of stronger material or weaker material than the original beam? Come on, tell me the answer. Okay, Naman is saying the use of flinches is to increase the load carrying capacity. That is the moment of resistance. Very good. Very good. Very good. And Naman is saying the next part is made up of stronger material. It is made up of stronger material. Yes. Others, please reply. Please reply. Others also, please reply. Yes. Navraj, Abhinash, Sunil. Yes. Stronger material use. Okay, very good. Very good. Yes. Very good. Very good. Because we know as we move away from the center, the Z will increase. And if I take a stronger material, obviously then we get the higher strength, the higher moment carrying capacity. Okay, so that's all till here. One last slide we are discussing. This is the last slide that we are going to discuss with the questions. First question: if the layers in bending are not bonded, will any shear develop in the beam? Will any shear develop in the beam? When I am saying about the shear, it is linked with the bending. Shear means I'm talking about the longitudinal shear. There are two types of shear I've discussed. One is a transverse shear, other is a longitudinal shear. So I'm talking about the longitudinal shear that is developed due to bending. So what I'm saying that if the layers are not bonded, will any shear in the longitudinal direction will develop? Yes, please everyone, it's a request to like the video and share with your friends, right? I want this initiative to be enhanced by you all, right? You motivate us more. Yes sir, you are doing very good for us, and for that we are doing everything. Okay, yes. Will there be any shear in the longitudinal direction due to the bending if the layers are not bonded? If the layers are not bonded, will any shear develop in the beam? Yes. Obviously I'm saying that there is no bond. Yes, मैं आपको बोल रहा हूं कि shear क्या डेवलप करेगा बीम में अगर लेयर्स में बॉन्ड नहीं है ड्यू टू बेंडिंग. बोलो भैया, will any shear developed in the beam if the layers are not bonded? Yes. Now listen to me very carefully. If you have seen my lecture, you should answer this. I've told you that if there is a bending, if the bending will occur, so each layer will try to expand differently. हर एक layer अलग अलग तरीके से expand करना चाहेगा, लेकिन वो उसका shear होगा जो उसको एक प्लेन सेक्शन बनाएगा. तो अगर ये बॉन्ड नहीं है, if the bond is not there, obviously there will be no shear. So answer is no. Right? There will no horizontal sliding force. Okay. Is it clear to all? Right. Is it clear to all? Good question, right? Created problem with you all, right? Yes. So you should understand these points. Okay. So if the layers are not bonded due to the bending, there will be no shear. Okay. Next part. What is strain energy? What is strain energy? Come on, try to answer me this question. What is strain energy? Yes. What is strain energy? Yes, everyone, answer me this question. What is strain energy? What you are going to define? You are going to say that when the external load is applied on a deformable body. So when you apply the load on the deformable body, right, then what will happen? It is going to deform. वो deform करेगा. And if it is going to deform, the work done by the external load, जो external load जो काम करेगा, that external load will stored in the body in the form of energy, and this energy is referred as strain energy. Right? Sunil and Durgesh, when I say there is no bond, that means there is no friction. Okay, when I say there is no bond, that means there is no friction. Okay, when I say there is no bond, that means itself that there is no friction. Is it clear? Right. So energy stored in the deformable body due to the applied load by the work done by the external load is the strain energy. Okay, that's it. Next, what is the difference between resilience, proof resilience and modulus of resilience? What is the difference between resilience, proof resilience and modulus of resilience? Yes, what is the difference between resilience, proof resilience and modulus of resilience? Come on, who can answer me this question? What is the difference between resilience, proof resilience and modulus of resilience? Yes, hypothetical condition, very right, Naman. Hypothetical condition of no friction. Yes. What is the difference between the resilience, proof resilience and modulus of resilience? Come on, answer me. Yes. Resilience is nothing but strain energy. Proof resilience is nothing but strain energy. Modulus of resilience is nothing but strain energy. But all this strain energy is due to static load, right? So when I say resilience, it is a strain energy within the elastic limit. When I say proof resilience, it is the strain energy up to the elastic limit. When I say modulus of resilience, it is the strain energy up to the elastic limit per unit volume of component. Per unit volume of component. Right, that is your modulus of resilience. Yes, so very simple. Next point. What is creep? What you are going to define for a creep? If someone asks you any question that what is creep, how you are going to define that? How you are going to define the creep? Okay, how you are going to define the creep? Yes, what is creep? What is creep? How you are going to define the creep in a material? Yes, what is creep? We say that it is a plastic deformation. We say that it is a plastic deformation developed in a material due to the dead load or constant load. Right? It is a plastic deformation that developed in a material due to the dead load or constant load over a period of time. Over a period of time. That's it. This is the only thing that you are going to say. If they ask you further that what are the factors affecting the creep, then you can say time, then you can say loading, right? Then you can say temperature, right? So all these you can say thereafter. Okay. Next. What is the difference between the toughness and modulus of toughness? What is the difference between toughness and modulus of toughness? Yes. What is the difference between toughness and modulus of toughness? So what we are going to say? It is a strain energy developed in the material due to impact load. First thing. Second, toughness is a strain energy developed in the material up to the failure, right? Till just before failure. So that is a strain energy. And if I talk about the modulus of toughness, it is a strain energy up to just before failure, right? Per unit volume of component. Per unit volume, the volume of component. Right? Next, what is fatigue and endurance limit? What you are going to answer in this? What is fatigue and endurance limit? What is fatigue and endurance limit? What you are going to answer in this? What is fatigue and endurance limit? So we know that what is fatigue? When the reversal of stress is there, when a matter is subjected to stress reversal, then the failure of the structure is referred as fatigue, right? And if we need to design a material for this fatigue, that means the failure should not occur for this reversal of load, then we select a limit, we select a strength of the material that is less than the yield and ultimate strength of the material, and this limit is referred as endurance limit. This limit is referred as endurance limit. This limit is referred as endurance limit, right? So all these were the questions which I need to discuss today. Right? These were the questions which I need to discuss today. So one announcement I'm going to make. The announcement is there is a marathon session on the special class in the Unacademy Plus channel. Right? That's Unacademy channel. Right? Unacademy medium. Right? That's a marathon session on the principal stress. I'm going to give the complete revision on the principal stress in this marathon session. So I would like everyone to join this session and please revise this session very properly. Okay. So those who are planning for subscription, I already told you what are the advantages of the subscription. The classes will be in English and Hindi. Doubt clearing sessions are there. Weekly tests are there. Rank improvement batch is there. Crash course, live classes, everything is there. Right? Those who are planning for subscription, what they can do? They can go to the Unacademy Plus either on the app or on the site. Select your goal. Go for get subscription. Use the code BHAR10 for the subscription. Prefer either 12-month or 24-month. And you can go for EMI option also through 3 options. Either debit card or credit card or your Bajaj Finance. Right. Thank you so much. I hope you enjoyed the session. I hope you liked the session. And if you like the session, it's a request to share this video with your friends more and more. Okay. Yes, Avinash, telling you very clearly, the bilingual is always entertained in the interview. That's not a problem. But since here all the students from North and South have joined, that's why I have preferred the English option, because most of you can understand English, right? I'm not making it as a preference for me, but most of you since can join the English, that's why I've taken this option. Okay. Yes. Anything you want to ask, you can ask from me, not a problem. Yes. And before ending, I want everyone to write my code. The code is not there, the coupon code is not there. I want everyone to write the code in the comment box. Yes, I want everyone to write the code in the comment box along with let's crack it. Along with let's crack it. Yes, Abhinash, yes, this subscription is both for mains and pre. This subscription is both for mains and pre. You can contact me for the subscription. That's not a problem. Yes, I want everyone to write my code and let's crack it. Yes. Yes, yes, yes. Everything. Interview also, mains also, pre also, everything is there. Everything is there. Yes. So anything you can ask from me. Not a problem. Anything. Yes, anything you want to ask, you can ask from me. Yes, how many of you remember my code? How many of you remember my code? Let's see. Yes, I want to see that in the comment box. I want to see in the comment box. Yes, rank improvement batches are there, Sunil. Rank improvement batches are there. Right, we have already started those batches for all the pass out students. Right, there we are having 250 to 350 questions dealing over there. Right, so any problem you are having, can contact me or my team, anyone if you like, right? You can contact them, not a problem. Yes, anything you want to ask, you can ask from me, dear. Anything. And please join me on the special class for the revision of principal stress. That's a marathon session of 2 hours, and try to complete all the topics in those 2 hours for your revision. Yes. So Sunil and Avinash, you can contact me personally, but not a problem. Okay. Yes. Thank you, Sunil. Air pressure on your head. What is the air pressure on your head? Tell me, what is the air pressure on your head? You are at which level? You are at which level from the zero surface? That you should understand. The higher you go, the air pressure is going to decrease. Yes. Yes. Okay. JD Patel, you told me that, sir, you start the interview session. I will bring my 200 to 300 students to this channel. I would like to see that. I would like to see that. Yes, JD. I would like to see that. Yes. Okay. Anything else you want to ask? Yes. Anything else you want to ask from my subject? From my subject. From my subject. From my subject. You can ask this question from a fluid mechanics faculty. Aniket, you can ask this question from a fluid mechanics faculty, not a problem. Yes, you can ask this question from a fluid mechanics faculty. Yes. एकदम मैं जो भी प्रीवियस ईयर में पूछा गया है मैं सब सॉल्व कराऊंगा. ये तो अभी स्टार्ट हुआ है बेटा, ये तो अभी इंटरव्यू सेशन शुरू हुआ है. ठीक है, जैसे मैं स्वाम ले रहा हूं, मृगान सर एनवायरमेंट का लेंगे, या चेतन सर आपको हाइड्रोलॉजी इरिगेशन इन सब का लेंगे, कोई जियोटेक का लेगा, इस तरीके से चलता रहेगा। Yes, I want everyone to come to the special class at 8 p.m. for the principal stress revision. I want everyone to come on the special class for the principal stress revision. Okay, right. Thank you Aniket, thank you so much बेटा। टॉस में मजा आ गया ना, अभी बहुत मजा आएगा, टेंशन मत लो। शेड्यूल यही रहेगा, हर संडे आपका इंटरव्यू सेशन प्लान्ड है 6 to 7। शेड्यूल यही रहेगा इंटरव्यू सेशन का, 6 to 7, 6 to 7 इंटरव्यू सेशन पर संडे, 6 to 7 इंटरव्यू सेशन पर संडे, 6 to 7। ठीक है, पर सेशन इंटरव्यू सेशन, पर डे, पर संडे इंटरव्यू सेशन 6 to 7 PM। अरे रोज रोज कराएंगे पक जाओगे, करना बंद कर दोगे, इसलिए हर चीज को समय देना चाहिए, है ना। ओके, एनीथिंग एल्स यू वांट टू आस्क, एनीथिंग एल्स फ्रॉम द टॉपिक्स? सर टॉस हिंदी में, मॉस या टॉस? टॉस इज थ्योरी ऑफ स्ट्रक्चर, टॉस इज थ्योरी ऑफ स्ट्रक्चर, राइट। स्ट्रक्चर अभी तो ऐश्वर्या सर लेंगे, ठीक है। मैं आपको स्वाम लिया हूं, स्वाम हिंदी में आएगा, स्वाम हिंदी में आएगा, बट अभी टाइम है, अभी टाइम है, अभी टाइम है। और मैं बताऊं, अगर मॉस आया तो आप लाइव बोर्ड पे पढ़ोगे, वो लाइव बोर्ड पे पढ़ोगे, मतलब ऐसा रहेगा कि क्लासरूम का फीलिंग आएगा, इतना मैं बोलता हूं, इतना मैं बोलता हूं, ठीक है। लेकिन आपसे एक रिक्वेस्ट है यार, ये वीडियो वायरल करना आपका काम है, शेयर करना आपका काम है, ये आपका धर्म है शेयर करना। आई वॉन्ट एवरी वन टू शेयर दिस वीडियो विथ योर व्हाट्सएप, जो भी मेरे से कनेक्टेड है। डिफरेंस बिटवीन ट्रू स्ट्रेस एंड इंजीनियरिंग स्ट्रेस बहुत आसान है यार। ट्रू स्ट्रेस क्या होता है? जब आप लोड अपॉन इंस्टेंट एरिया बात करते हो, जब एरिया डिफॉर्म है उस एरिया पे बात करते हो किसी इंस्टेंट पे, तो वो ट्रू स्ट्रेस देता है। इंजीनियरिंग स्ट्रेस क्या होता है? जब आप ओरिजिनल एरिया को कंसिडर करते हो तब वो इंजीनियरिंग स्ट्रेस देगा, ठीक है। बाकी और कोई सवाल है तो बताओ। यस, ओके, थैंक यू सो मच। आई होप यू एंजॉयड द सेशन, राइट, आई होप यू एंजॉयड द सेशन, राइट। ऐसे ही ऐसे और इनिशिएटिव्स लाते जाएंगे, और आपसे बस यही रिक्वेस्ट है कि प्लीज इंटरैक्ट विद अस मोर, शेयर आवर वीडियोस